machine learning topic clustering. Before goes to the clustering, I want to tell you something for you people. Uh, Under the machine learning, we have the two types of data. One is the training data with tables. Till now, we are working on this one. For example, we have the house information with house price also. So we are providing this house price, what we call it as a dependent data. So while building model till now, we are provided independent variables with dependent variable. A dependent variable is nothing but the labels. Labels for example, let's take the spam or not spam problem. Here, whether it is a spam or not spam is the label. Label for that particular data. For example, if we have the 100 records, out of the 100 records, 70 are the spam and 30 are the non-spam. What we are saying output, that is the dependent variable, whether it is a spam or not, we call it as a labels. Till now, we deal with this data, training data with labels. We call this type of data is the supervised learning. So you have a dependency to estimate. So here we have the dependent data to estimate the uh, output value. But there is some other type of data, training data without labels. Without labels means, for example, let's take the same example, librarian example. We have the library, a lot of books are there. But for the safe side, the people who are the supervisor of that library, he entered all the files information into the his laptop. He saved that information in hard disk. Due to some fire accident, we lost that library, all the books. But we have the all books information as each book. We created a file for the each book and we stored in the folder. But we don't know the file whether it is belongs to the maths or physics, chemistry, some other GK computer. Just we have the all books files. We have the all books information. But we don't know whether it is the maths or physics, GK, like that. At that time, how do we find, how do we separate maths files, social files, physics files separately? For example, if we have the some sample data with labeling maths, physics, chemistry, what we will do? We'll build model for the remaining 1 lakh files, we'll send each and every file to the model. It will automatically predict whether it is a maths, physics, chemistry. For example, we don't have single file with label. At that time, what we need to do? That type of data, which data doesn't have dependent variable, that type of data is the unsupervised learning. Here, in the supervised learning, we have the input and output. So we'll learn uh, as a manner with, for example, here if we say the new record is maths or physics, we are able to say why we are saying it is a maths and physics with reason. With reason means how, what is the reason? We are saying we already have the some trained data. In that same trained data, we have the label maths. Based on that maths label, we have collected that information. That whenever new file comes, this file information is near to those files information. That's why I am saying it is the maths. So here we are able to supervise learning means we are able to do prediction with reasons. Whatever the information we are providing, we say it, that is the reason why we are predicting it as a maths or physics. Coming to the unsupervised learning, here based on the information similarity, we will cluster. We don't have any labels. We don't have any proofs whether these files are belongs to this group, these files are belongs to this group. We don't have that type of information about these data. So under supervised learning, we are considering two types of machine learning. So one is the regression and another one is the classification. You people already know whether the dependent variable is the continuous numerical value, we'll go for the regression. Whether the dependent variable have the nominal or ordinal categorical value, then we'll go for the classification. Okay. Coming to the unsupervised learning. Here, we don't have any information about the particular file. At the time, what we need to do? For example, let's take some guy comes to you. He provided some grains which are related to the Mausami, some other. What you people do? But you don't know the what is the name of that grain. But what you people will do? You people will take, will observe something. What is the shape of that grain? What is the color of that grain? Uh, Based on that grain characteristics, that means a shape, color, size. Based on that, you people able to group those grains. Is it right? For example, some guy gives 10 different grains to you. He want to cluster the separate these grains based on the grain type, but he did not provide what is the name of those grains. So you don't know what is the name of 10, whether that grains have the 10 different types, 5 different types, 6 different types. But you have the grain. You don't know names, but based on the color, based on the size, based on this some shape, based on the taste, you people can able to to group those grains into the 4 groups or 5 groups. Whatever the difference you observe. Okay, that is the same concept we are using here. Based on the meaning, based on the data, based on the patterns existed in the data, we will cluster. We will cluster that data into 2 groups or 3 groups, 5 groups. How many different patterns we identified in that data, that many groups we will form. Okay. Outlier detection. Outlier detection means, let's say, while grouping this one, let's take, we have the, he provided grains, 1,000 grains. Out of the 1,000 grains, some grains have the, some type of grains have the 100, like till 900. But the last 100 grains, it have the 100 different types, at least 50 to 40 different grains. For the each one is the 1 or 2 grains only. For the one type of grains, we have the 100 samples. For the another, we have the 9 different grains with 100 samples. But some 50 or 40 different grains have the 1 or 2 samples. 1 or 2 sample grains. What we call, based on the characteristics, the difference between that and the remaining 9 groups pattern to these 50 groups pattern, we we are able to identify those are the outliers. Okay, like that.
Okay.
Associating rule. Associating rule means, for example, let's take one guy enter into the retail shop. Okay, he installed Amazon or Flipkart online shopping. He ordered baby milk. Then after, he ordered baby powder. Automatically, what that e-commerce center will do? Automatically, that e-commerce center suggests some baby oils. Why? Because he had buy baby milk powder, baby milk, for example, some diapers, some other things. So based on the what he purchased, we are suggesting. So he is the guy who have the baby. That's why he is purchasing some items related to the baby. That's why we will suggest baby oils, baby lotions, baby powders, baby soaps, like this. Why? Because to attract that customer. If maybe he joined to purchase only baby milk, baby powder, but if we suggest baby oil, baby shampoos, maybe there is a chance if he forget to buy something, whatever he doesn't have in his home, automatically he will buy that one also. That is the some trick
Yeah.
the e-commerce centers play on the customer based on not only that. For example, sometimes a guy goes to the major shop. He purchases meat. Then after he purchases something coriander leaves like that. Then after he purchases other things. Whenever new customer comes, he purchase meat. What he does based on the previous customer experience, what he buy after meat, coriander leaves, after meat, ginger garlic paste like that, it will suggest same coriander leaves, ginger garlic paste like these type of items to the new customer also. So so based on the patterns, customer interest on which way the customer interest goes, and that way by recognizing that pattern, association rules e-commerce sites uses some suggestions of the products. For
Okay.
example, let's take the Google search. So whenever we type one or two words, the websites which are have those names, it will automatically suggest something based on the meaning of whatever we are searching, based on the meaning, based on the words presented. Is it right? That is the association rule. Here we are not building any model for the with the supervised learning. Here we have the some model, some patterns, different patterns information we have the. We will store that pattern information based on that pattern. For example, whenever new customer comes, mm, after he adds some products what he wants to the ad cart, based on his these products, it will identify the pattern of is there any same pattern previously they are some other customer previous customers ordered in their website. Okay, this is the pattern recognition of the data. Here we
Okay.
don't have the any information about the data, just we have the data. So based on the patterns and characteristics of the data, we need to group into the clusters. That is the concept. That is the unsupervised learning concept. Okay.
Okay.
So you people now able to understand what is supervised learning, what is the unsupervised learning, how we are building models by using supervised learning, how we are building models by using we'll say how to build models with unsupervised learning data. Okay.
Yes.
So see, in supervised learning, estimating on the unknown dependency, that is the y equal to f of x. Here we are providing input variable. We will have the one formula. For example, for the regression model, y equal to mx plus c. Y actually it's beta naught plus beta 1 x1 plus e. E is the error. Why I am saying always y equal to mx plus c? From the starting on our 6th to 10th, we had that formula y equal to mx plus c lot of times. That's why whenever I say, you people will feel it is a very familiar equation. That's why I am saying y equal to mx plus c. Actually, it is the y equal beta naught plus beta 1 x1 plus error. Okay.
Okay.
So we will take that type of equation to find the dependency. Will whenever new data come, we'll predict that one. For
Yes.
example, let's take some examples. Given age, gender, income, marital status, predict the loan default risk. Here, these age, gender, income, marital status, these are the independent variables. whether he has take whether he is a loan default variable. So here, while training model, we will provide both the informations: input variables age, gender, income, matter status, with whether the customer defaulted on EMI repayment within the next 24 months. That information also we will provide. This is the supervisor learning.
Yes, ma'am.
Yeah. Coming to the cluster. Cluster are the similarity groups in data. For example, dis- data instances that are similar to near each other in same cluster. So, if whenever we perform one cluster, for example, we have the lot of data, we perform clustering model. We grouped some two or three groups, but on which basis we are grouping? The data points in that clusters are very near compared to other group. For example, there are two clusters. We did two clusters on the given data. The data points which are presented in the group 1 are so far to the data points which are presented on the group 2. Based on that intuition, we'll do the different clusters.
Okay.
Yeah. For example, let's take this one. We have the what is the natural grouping among this. Here we have the lot of people. Here we have the lot of people. What we'll do? Based on their characteristics, we are able to find families. Or let's take in this group, we clustered only females. In this group, we are clustered only males. In this group, we clustered only school employees. Based on their gender or whatever the information we are providing about these people, we will cluster. For example, if we are providing their educational details, we can able to group these guys are related to the degree, who completed BCommerce, who completed MSc, who completed engineering, who completed M Pharmacy, like that. If we are providing only gender and age, we are able to, if we are providing gender and age, what we'll do? Based on those information, we'll cluster female, male. Under female, uh, child, adult, and elders. Under male, child, adults, and older people. So, based on the data what we have, we will try to group the people. That
Okay.
is the clustering. For example, let's take we have the images database. Lot of images database. What we'll do? For example, let's take these are all related to the sky. These are all related to the greenery. These images are the sun, sunrises, something. So, based on the characteristics in these images, what we consider based on the color, based on the pixels, based on the image size, we will actually computer doesn't know whether it is the sky, whether it is greenery, whether it is sun, nothing. But based on the pixel colors, pixel size, it will group images into the different groups. Just if we provide text to the clustering, what it does, it collect the all names, location names, dates, some after applying NER, we are able to find whether, for example, let's take the pharmaceutical documents. Through the pharmaceutical document, we are able to group all dosages, one, all strengths into one group, all chemical names into one group, all product names into one group, all drug names into one group, like that, based on the distance between the one data point to the another data point where we will cluster. So this is the some concept we are using in our cluster machine learning model. Here we have the two types. For example, hierarchical approach. Create hierarchical decomposition of this set of data using some criterion. In this, we have the partitioning approach also. Partitioning approach means, for example, first we don't know the all data points information. What we'll do, based on the first we will, for example, let's take the grains. Based on the first what we are able to identify easily, color. So we will take that is the main parameter. Based on that parameter, first we'll partition uh, all data points into different groups. Then after, within the color, there might be different shapes. So what our next parameter will take, shape is the next parameter. Based on the shape also, we will partition into the data points into different groups. Like that, we will approach partitioning approach. For example, what we call it as the K means error. K means clustering or spectral clustering. Both are the same. We'll say details about the K means hierarchical in this session only. Model based methods. For example, a model is hypothesized for each of the clusters and tries to find best fit for the model to each other. This is, for example, after at the initial stage, we don't know the how many different patterns presented in the data. What we'll do, if we don't know how many patterns, if for example, if the data have the 10 different patterns, we need to do 10 different clusters. So at that time, this hypothesized cluster tries best fit for the model each other. For example, this is the one of the concept, LO concept, I will introduce in this session only. These are the just different algorithms related to the clustering. You people already know, whenever we build model, we need to check whether the model is performing as expected, whether it is giving good results or not. Here, we need to check our quality of the clusters also. How do we do that one? Here, we will use two different approaches. One is the intra-cluster. Another one is the inter-cluster. This is the compactness, this is the isolation. What is the difference between these two means? For example, cosine measures how near the data points in a cluster are the cluster centroid. For example, we clustered one group of the grains into one. Then after, what we will do, we'll take what is the data point in middle of that cluster, we'll take that is the center. Then after, we will calculate what is the distance between the each and every data point in that cluster to centroid. So, if the distance between the each and every data point to that cluster is very near, that means very less. So, based on that information, yes, the data point between the cluster centroid, the distance between the data point to the cluster centroid is very less. So, whatever data points we used for this cluster is the correct. At the same time, we need to check other thing. That is the separation means the different cluster centroids should be far away from one another. There is the two things. We have grouped into the two or three clusters. three clusters, we need to check the data points which are in the same cluster. The distance between the each data point is very less. At the same time, the distance between the two clusters also very far. If guys, just a minute. So, for example, let's take if the two clusters are very near, whenever new data point comes, if that data point lies, if that data point have the same distance between the cluster 1 centroid, cluster 2 centroid, so at that time we are not able to take decision whether this new data point comes under cluster 1 or cluster 2. So we need to check what is the distance between the two cluster centroids also. We need to maintain the distance between two cluster centroids. It will be every time more. So then only our model gives good results. So we need to check whether the data points are near to centroid or not, in the same cluster. At the same time, we need to check is there whether the distance between the two clusters are very high or not. Yes, possible. Yes, I won't say every time it's possible. The distance between the two clusters is a very high, but we need to check whether whether the distance between the data point to the centroid is always lesser than the distance between the two centroids of the two clusters. Okay. If the distance between the two centroids of the two clusters and the distance between the data point to the that cluster data centroid, if both are near, that means those both clusters will comes close together. So whenever new data point comes, so we need to we will fail to predict whether that data point comes under cluster 1, cluster 2. Okay, I hope you people can understand why we are taking these two parameters as the metrics for the cluster quality.
Ma'am, means, can you please show us some means a kind of graphical thing in Paint,
Yeah, sure,
in
sure,
MS
sure.
Paint? Yeah, ma'am, please.
These are just for you people to understand the concepts. Then after we'll say, see, this is
Mhm.
the K-means clustering. Here I introduce only algorithms, that is the hierarchical partitioning. The partitioning is nothing but K-means model based. Here we'll explain everything clearly.
Okay.
Yeah. K-means is a partitional clustering algorithm as it partitions the given data point into K clusters. For example, let's take that we have the K clusters. We need to find centroid for the each and every cluster. What is the center point in that cluster? But how many groups we want to do that, the user, whoever want to build model, that's their choice. Whether if he wants to two cluster, three cluster, four cluster, that's his choice. If he is not able to say how many different groups or how many different patterns presented in that data point, we have other approach to identify the clusters also. We'll say that approach also. First, what we'll do, for example, K means, for example, we have the different library files. What we'll do, based on the terminology presented in the file, we will group. Okay, for the mathematical files, their terminology is different for the physics, chemistry. In chemistry, we will get only most of the terminologies are chemicals. In maths, most of the terminologies are the mathematical algorithms. So, like based on the terminology, what we call as the patterns. So, based on that patterns, it will be partition. Data points into the two or three partitions. This is the concept. Let's see. First, for example, let's take it will follow four steps. Actually, I created these steps to understanding. First, randomly choose k data points. Actually, whenever we see data, we don't know how many different patterns presented on that data. That's why you just initially you can select something, some value for the k, whether it is 3, 4, 2, whatever, and to be the initial centroids cluster centers. Then after, assign each data point to the closest centroid. You can take, for example, I have selected 4 clusters. I have selected 4 clusters. So I have selected 4 data points which are so far to each other. I won't take the 4 data points which are very near. I will take the 4 data points which are so far. Then after, we'll calculate the distance between the each data point to the each cluster. For example, I have the 100 records. I have selected 4 data points. Why? Because my initial intention k value is 4. So remaining, how many records we have? 96. Is it? What I will do? We'll calculate the we'll select one data point. We'll calculate the distance between that data point to the each and every cluster centroids, whatever I have selected 4 data points initially. For example, cluster 1 to data point is the 4 centimeters. Cluster 2 to data point is the 5. Cluster 3 to data point is the 2.5. Cluster 4 to data point is the 6. Which cluster centroid is very near to that data point? Cluster 3. Why? Because the distance between the cluster 3 centroid to that point is the 2.5. Remaining are 4, 5, 6. So what I will do? We'll assign that data point to the cluster 3. We'll repeat the same process for the remaining 95 records. We'll calculate the distance between the each centroid to the particular data point. Which distance for the which centroid to that data point distance is very less, will assign that data point to the that cluster. How many times I will iterate? How many data points does I have? I will iterate that process that many times till I am able to partitioning all data points into the how many groups I want to do. I hope you people can understand now.
Yeah, ma'am.
Yeah.
Somewhat.
So what will happen at the end of the clustering? We have the 4 different centroids. We have the different data points, but those data points, for example, cluster 1 have the 10 data points. That means those 10 data points are very near to that cluster. That means those 10 data points patterns are similar to the cluster 1 centroid. But these patterns are not similar. There is some variation to the cluster 2 data points or cluster 2 centroid. There is some difference on the pattern of cluster 2 data points and the patterns of cluster 1 data points. So we need to concentrate on the similarity and differentiation. Why? Because why we need to concentrate on the similarity? To group the clusters. Why we need to concentrate on the differentiation? We need to separate two clusters. Based on that difference only, we are able to separate those two clusters. That's what the sign. Assign each data point to the closest centroid. The data point which centroid is very near to that data point will assign that data point to that cluster. Recompute the centroids using the current cluster memberships. That means, let's say I have differentiated uh, 4 groups. Then after we need to check, for example, whether the whatever data point we selected as a centroid, whether it is near to all data points or not. Then after we need to select which we need to calculate which data point. In this cluster we have the 10 data points. Out of the 10 data points, which data points have the same distance, same means approximately same distance for the each data point. So based on that, we need to reselect the centroid also. So we'll do same steps if convergence criterion is not met. If some clusters don't get any points, go to 2. That means some due to some outliers, there is no we can't able to cluster those outliers. Why? Because those data points are very far to the each and every centroid. For example, I have selected 4 centroids, but some data points which are very far to these 4 centroids. So we'll say how to we do. These are some mathematical expressions. For example, reassignments of data points to the different clusters, change the centroids, minimum decrease of the sum of squared errors. These are the some equations to calculate the distance between the data point to the centroid. Here, I will explain about the reassignment of the data points, change the centroids, minimize the why we need to change centroids. For example, as Akash asked, I will explain through the graphical answer. As example, here we have these all are the data points. Okay. At the
Okay.
first time, I have selected this yellow color, this red color, this blue color are the centroids. These 3
Okay.
points. Okay, this one, this one, this one.
So, ma'am,
Then
we
after,
can, sorry to interrupt, but we can select any of the point means randomly or,
yes, actually at initial stage, you people don't know the how many patterns presented are there.
okay,
First, for example, let's say we have the grains. What we'll do? Whatever the grains which are different, first we will select those grains. Then after we will compare the each grain to the each. For example, we have the 5 different grain. What we'll do? We'll first select. We'll first pick one grain which are differently. We'll put in the 5 places. Then after what we'll do? We'll take each and every grain, whatever the grain we have taken, which is similar to in out of the what we selected initially 5, we'll put in that groups.
okay,
Okay. Here also same thing we will do. We will select 3 points. For example, I want to group the data into the 3 points. That's why I have selected these yellow, green, blue. If you believe 5 or 6, you can take 5 or 6 data points.
o-
How many groups do you want to do? You can select that. That is the number. Here, I am observing 3. That's why I have selected yellow, red, blue. This is
Okay.
first we will do. Then after what we will do, we'll take another data point. We'll calculate the distance between this point to this point, this point to this point, this point to this point.
Okay.
So we have the three distances. For example, the distance between these two is very less than compared to this one. We'll assign this data point to belongs to this cluster.
Okay.
Same thing we will repeat for the all the data points. Whatever how many data points we have in the data.
And
For
ma'am,
example,
how will means measure the distance? Means we have formula. Mm,
yes, we have formulas. That is the SSE, sigma of
okay.
distance of x and m. Here
Okay.
CI is the J cluster centroid. That is the what we initially selected as a centroid. MJ is the centroid of the cluster. Jth cluster, mth cluster. For example, another cluster. Mean vector, all the data points, Cj. Here we are calculating for the each and everything.
Okay.
These are this Mj is the center of the centroid of the cluster Cj. This is the Cj is the point. Here we have the J, I.
Okay.
J is the cluster, I is the data point related to that cluster. So we will calculate the distance between the each data point to the centroid. Here we
Okay.
need to, yes, for example, maybe we are it's enough to take one sigma. Why do you people have taken, ma'am, two sigmas? Means one is the data point, another one is the cluster. So if we have taken one data point, we need to calculate distance between the each cluster. If for example initially if we selected four clusters, for this data point we need to calculate distance these many clusters. How many clusters we have? We need to, then after we will assign that data point to the cluster. Then after we will take another data point. We will calculate distance between that data point to the all the clusters. That's why here they provided two sigmas. If you people want to understand clearly, I will say in the for loop. First, what we'll do, we'll provide one for loop for the each data point. Then after, from the for loop, what we will get out of the 100 data points, first we will select one data point. Then after, again we'll give one for loop. That is for the centroids. Initially, I have selected 4 or 5 centroids. We'll give uh, for loop for that centroids also. What we'll do, in the first for loop, we have collected one data point. In the second for loop, we will calculate the distance between that data point to the how many clusters we have selected. After finding that distance, we'll assign that data point to the some cluster. Again, it will go for the first for loop. It will select another data point. Again, it comes to the second for loop. Here, it will calculate the distance between this second data point to the each and every cluster. Again, it will assign that data point to the some cluster. These two for loops repeated till the all data points we cover. Got it?
Yes, ma'am. Can you please go into that diagram and please explain about the loop, ma'am? How the loop will.
Yeah. That's what I will. These are the some centroids to calculating the centroids, radius, diameter, everything.
Mhm.
Let's take, for example, initially I have selected three groups, three data points, yellow, red, blue.
Yes.
Okay. Then after I will select one thing. This is the data point.
Yes.
We'll calculate the distance between this data point to this centroid, this data point to this centroid, this data point to the centroid.
Mhm.
I have the very less distance between this data point to this centroid compared to the distance between this data point to these two centroids. That's why
Yes.
I assign this data point into this group. Then after I go for this data point. Again, I will calculate the distance between this data point to this group, this data point to these two groups also. Again, I have selected this data point.
Okay.
Again, I calculate the distance between this data point to this cluster centroid, this cluster centroid, this cluster centroid. I got that the distance between this data point to this centroid is very less than compared to this data point to these two centroids. That's why I assign this data point to this cluster. Okay.
Okay.
But yes, I repeated this operation for the each and every data point. Okay.
Okay.
Now I got the this is the one group. This is one group. This is one group. But I won't leave like this. For example, let's take whenever new data point comes, which is lies here, we don't know whether that data point belongs to, for example, the data point to distance between this centroid to this data point to this centroid, same.
Yes.
So we can't say whether that data point comes under yellow group or red group. For that purpose, what we need to do in k-means means after grouping these points like this, again we will recalculate the centroid. Centroid means we recalculate the distance between the each point to the each point. For example, these are the some data points I have in yellow group. Okay. We'll
Okay.
calculate the distance between this point to all the data points which are presented in here. After the data point, for example, let's take this one. This is have the uh, less distance between the each and every data point. Let's take if you have taken this data point is very near to these data points, but it is very far to these data points. Yes,
Yes.
but let's take this data point as the centroid. What will happen? The data points all are compared to remaining data points. This data point is very near to the all data points.
Yes.
So, like this, we are recalculate the centroids for the each group.
Okay.
Then whenever new data point comes, it's easy to identify whether it is belongs to which group, whether it is blue or yellow or red. That's why we need to recalculate centroids. That's what I said here. Here, reassignment of data points to the different clusters, no or minimum change of centroids. We need to change centroid. Again, we need to calculate then now we are getting the real centroids. First time we don't know the which what is the centroid for the each cluster. That's why we are selecting some points as a cluster centroids. We'll assign some groups. Again, after assigning that group, we'll again calculate the what are the real centroids. Then after we will again calculate the distance between the centroid to the each points. We'll reassign the data points. Okay.
Okay.
Why? Because initially let's say Akash, if initially we know the how many patterns presented in the data point, we don't need to reassign centroids recalculating. But initially we don't know how many groups are presented in the data. That's why randomly we will select some centroids.
Yeah.
Then after while recalculating centroids, then while again recalculate the distance between the each point to the centroid. Maybe if is there any points, for example, let's take same example. Actually, I have selected this is the centroid initially, but after a reassigning cluster, what will comes? These 3 points will comes under outliers, and this one, if this is the centroid, maybe these two will comes under the outliers. Is it right?
Yeah.
Yeah.
Yes.
So if we are able to, if we recalculate the centroid, then after we'll check whether the data points belongs to this cluster is really belongs to this cluster or not. Again, by calculating the distance between the this centroid to the each and every point. If, for example, while recalculating, we will get that these three points are very far to this cluster. For example, at that time, what we will do, we'll check whether these 3 points are very near or far. If these 3 points are very near, for example, or 3 points are lies between, what we'll do, we'll give separate cluster for this thing. But here these 3 points are very far, so we call it these are the outliers. So every time we are partitioning. First time I have partitioned three clusters. Then after I have observed some two different patterns in this cluster. What we'll do? Again we'll partition this cluster into the two groups.
Mm-hmm.
Like in this way, we are try to uh, differentiate different types of patterns. That's
Okay.
what K means will do. But you people already know we have a lot of algorithms, a lot of libraries, inbuilt libraries on Python. So don't worry about these formulas.
Mm-hmm.
Just these formulas are for to calculating the distance between the data point to the centroids and distance between the one cluster data centroid to the another cluster data centroid. Okay.
Uh,
Stability check. After
Ma'am,
grouping, we need.
sorry, ma'am. I have one doubt in that. Okay. Means
Okay.
we have we got. Please let me know if I'm wrong. Then we have different. We have three groups, right?
Yes.
So we calculated first of all by deciding random centroid, and then we calculated the distance,
Yes.
and we have got some result. Now we have selected one group, and then we selected one centroid in it, and then
Yes.
again we calculated the distance within that centroid also.
Yes.
So within that group, we got some data points which are very much far in the same group, and the far that the distance which are far, we designated that data points as an outliers.
Yes.
Okay, ma'am,
Yeah.
if a different or a new kind of data set again comes in between, then how, means, is it a chance, or means, I'm just
Yeah.
guessing that.
Yeah. Let's take regression classification model. We have the last 5 years data. Last 5 years data, we have the house information with price. After 5 years, shall we use same house information, same price for the new predictions? Whenever they
Mm,
mold, after 5 years, the prices will increase.
yes.
Definitely the prices will increase. At that time, we need to rebuild our model with new information. By using the last 10 years before house prices, house information data, if we predict the house price now, it will become definitely wrong predictions. It will gives very less house price they based on the region. What we need to do, we need to collect new the latest data to build a model. After 5 years, we need to improve our model by the with latest data. Let's
Yes.
see, a lot of the people, we have the Microsoft versions. Why those people are releasing version 1, 0.1, 0.2, 0.3? Why? Because whenever they release 0.1, their requirement is that one. By using that zero point 0.1 version, they are feeling maybe if this type of features is available in this version, it will be helpful for the users. What will they do? they again add that features, they will release version 2. After using version 2, if they feel maybe if some more features is available in this OS version, it will be helpful the user more than this, they will add that features also, they will release version 3. Same thing will repeat in our machine learning models also. Not only clusters, not only classification, regression. Whatever the model we need to build, if we want to use that model each and every year, we need to remodel that one with the latest data. For example, I have created one model based on the pharmaceutical data. Due to some corona, previously we don't have the corona disease. Now we have the corona disease. For this corona disease, some people who are the scientists, they manufactured or they researched something. They invented some new drug. Is this drug name is existed on the previous model, old models, my old machine learning model? No.
No.
So we need to rebuild our models with the latest data also
Okay.
every time.
Okay.
In clusters also, okay. Now we have in our data we have the 10 different patterns. So I have did 10 clusters. Whenever new data comes, maybe if for example, let's take the sweets. All are the sweets, but the taste is maybe different. Is it right? So based
Yes.
on the taste, based on the ingredients what we used to prepare that sweet, we will differentiate. Some chefs, they have what's their duty? They always try to invent new sweets to attract the users. So we need to rebuild our model every time.
Okay. We have to do the
Sorry.
recalculation.
Yes, yes.
Okay.
Don't think once I have built one model, that's it. Enough.
Mhm.
This model will work till end of the this for example, whatever the MNC company we are working, this model will useful for this company end of this IT software. No, we need to recheck, rebuild, rework on that every time.
Okay.
So, to check the stability of the cluster, take a random sample of 95% records. Same thing. uh, for example, let's see. In classification model, we will do, we will have the dependent variables. So that's why what we will do, we'll split into the um, we'll split into the 70-30%. By using these 30% records, we will calculate the accuracy of the model. How do we do in this same performance checking in our clusters? Hmm? After building model, what we will do? We will take 95% or 85% data randomly. First, I
Okay.
have the 100 records. I have grouped into the three groups. Then after, I have taken 90 or 80% data. Again, we'll rebuild the clusters 3. We'll check at the first time whatever the data points lies on the cluster 1, the same data points lies on the cluster 1 in second time are not. If the data points which are lies in cluster 1 same are again grouped into the cluster 1. The cluster 1 means same group, same cluster, not only cluster 1, cluster 1, cluster 1. The data points which are say one group, whether those data points again formed within that group, are those data points split into the different groups. We need to check like that one. We'll say that one in our Jupyter notebook. Don't worry, okay?
Okay.
But like that, we will calculate the performance. Choosing k value. See, I already told you we don't know the how many data patterns are presented in the data. So that's why we will randomly select two or three, four groups. But to avoiding that problem, we have the one method, that is the elbow point. Elbow point means One way to select k means algorithm is try different values of k. That means it will build one model with k equal 2. That means two clusters. It will calculate the data point, the distance between the centroid to data point and the distance between the one centroid to another centroid.
Okay.
Okay. It will calculate the distance also. Okay. For example, that is the some distance. It will repeat how many clusters we want. You can actually in this diagram we used five different clusters. 15. That's why it calculated for the 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. If you want to check with till 20 or 25, you can give how many clusters do you want to test. You can give that many numbers. Okay. It will give the on x-axis number of clusters, in y-axis k mean objective. Means we need to check uh, for example, see here till first cluster to second cluster. If I have taken one cluster, what will they it groups the distance is very near for each data point. Sorry, distance is very high.
Yeah.
For example, let's take the two clusters. We'll explain here. Instead of taking three clusters, I have taken only two clusters. One is this one, another one is this one. Okay,
Okay.
let's assume like that. What is the distance between this group to this point? Maybe these points we need to assign these data points to this cluster or this cluster. What will happen? The centroid to the distance between the points are very high.
Yeah.
So that distance is we are showing on the y-axis. Here we won't calculate the distance between the centroid to centroid. Here we are calculating the distance between the centroid to each data point. For example, whenever I have taken two clusters, the distance between the centroid to data point is very high. It is near to 2800, whether it is centimeters or meters. Like that, we will calculate the distance between the data point to the centroid for the each cluster. What is the distance between? Don't take, there are 90 data points for each cluster. Here we are measuring only one value. That means the distance here, the distance between the each point to the, sorry, the average distance between the each data point to the centroid. Here you people don't get confused. For example, this data point to this data point distance is 2 centimeters. This data point to this centroid 2. This is the 4, 5, 6, like this. We will get the how many data points are in this cluster present. For example, in this cluster 40 data points are presented. So we will get the 40 distances.
Yes.
Yes, centroid to 40 data points have, so 40 distances. We calculate the average distance of those 40 distances. Same thing for this cluster also. That average distance we are showing here. So the centroid to average distance for each data point is very high. We will do till the distance reduction is gradually decreasing. See, here the distance between the one cluster to two cluster is very high. The distance decreases very high. Cluster, after I build three clusters. So whenever I build two clusters, that average distance is very high. But whenever I grouped into the three, the average distance is reduced 2800 to 2000. Then
Okay.
after I build four clusters. Here the average distance between the data point to centroid is 1500 nearly. Again
Mhm.
1000. Again till 200. From sixth customer, sorry, custom not customer cluster, the distance decrease is very low. See, Here
Okay.
to here, the distance decreased gradually very high. From here
Yes.
onwards, the distance is very less. That means there are six different patterns presented in the data point.
Okay.
Yes, you people can understand this. How we select K, how we select how many data centers. Centers means how many clusters presented in that data.
Okay, ma'am. So,
So
the
let
yeah.
me let me okay. This is how we are how we cluster k-means by using the partitioning. Uh, then after these are the some metrics we used for the to calculate the distance, and this is how we are check stability of the clusters. Here, actually initially in k means we don't know how many different groups presented in the data. That's why this elbow point, this uh, concept will useful to identify the number of clusters in the data. So wherever the distance between the average distance between the data point to the centroid decreases, decrease starts. For example, we'll take let's take from first cluster to sixth cluster, the distance reduction gradually decreased. But here the reduction, that means the decrease of the distance is very less compared to previous one. That's why we have selected there are six groups.
Okay.
Yeah. Let's take why we are taking 6, why we won't take 12 10. Why? Because the distance between the centroid to data point compared to 6, 12 10 have the very less. What will happen? That means at that time, let's take this one. In this group only, for example, what is the, let's take this is one cluster, this is one cluster. For example, this is the centroid, here this is the centroid. What will happen? The distance between this centroid to this all groups, and the distance is the 7 centimeters. Let's assume it is the 7. Here the distance between this centroid to these groups are 6. Here also the distance between this group to these points also 6. What we'll do? We'll separate these two groups. This is the one group and this one is the one group. Whenever new data points comes under here, what will happen? Again we'll confuse whether this data point comes under this group or under this group. So that's why we won't take 7, 8, 9 clusters. Why? Because based on the, for example, let's take the, yeah, let's take the political something, political or students. Let's take the students. See, by there is the two groups, maths and BPC, CEC, some other. It's easy to differentiate the people who has taken rather than BPC, MPC, and the people BPC, MPC. Why? Because the subjects which are under MPC, BPC are, maybe there is a chance two subjects which is repeated in MPC and BPC. But compared to CEC and MPC, BPC, the subjects which are lies under CEC are so far to the MPC. Is it right? So what we'll do in this MPC, we have the two groups. Let's take the inter MPC 1, MPC 2, first year, second year. In whenever we do first cluster, we whatever the subjects lies under first year, second year, we are grouping into the same group. So what are the subjects MPC? Whether it is first year, second year, we grouped into the same group. But in with the 6 clusters. But we want to do more clusters, that is the 12. What will happen? We are doing separate cluster for the MPC first year, second year, YPC first year, second year group subjects. Whenever new subject comes which is related to the MPC and so it's very typical to identify that subject is comes under MPC first year or second year. So you can group, but don't group into deep level. Whenever we goes to the deep level, whenever new data point comes, we will confuse to assign the data point to the particular some cluster. That's why we are selecting this elbow is the data point. What is the some problems with k-means? K-means algorithm is sensitive to outliers. That is the one. Here, whenever this outliers comes, this k-means fails to identify the outliers. Due to these outliers, we are able to find correct exact cluster centroid. Let's take for this group, maybe this is the centroid. You can take this is the group, this is the centroid. If we want to include these one also, this will become the centroid. Why? Because this data point is the near to these points and these points also. If you have taken this is the centroid, this data point is near to this one, but this data point is so far to these outliers. Due to these outliers, our k-means model sometimes fails. So
Okay.
instead of taking mean value of the object a cluster as a reference point, midoids can be used, which mostly centrally located object in a cluster. That means you already know instead of taking average, it's better to take mean. Why? Because average we will calculate the sum of the all the data points. Whenever outlier presents, our average will changes. But let's take mean. What will happen? We'll arrange whether in ascending or descending order. We'll take the middle data, middle point. So there is no chance to affect with the outliers. Why? Because we are not including that outliers in the calculating part. So that's the same. These are saying instead of taking mean value, it is better to take midoids. How we what's the problem with midoids? We'll see here. More robust than K means in the presence of noise or outliers because a midoid is less influenced by outliers or other extreme values than a mean. That means let's take we call it as the outlier. Sometimes instead of outliers there may be random noise. Random noise means that's the same thing. Sometimes we miss the misvalues. Instead of filling with mean value, average value, sometimes people blindly fill with zeros. What will happen? It comes under the data point between the 0 to that centroid is very far, the midoid. So due to that reasons also our k-means will fail. So whenever we have the small data sets, it's very difficult to identify the patterns. Why? Because, for example, we have the 100 data records, we have the 10 groups. So for each group, we have the 10 data points. So how much information we will get through those 10 data points? We will get very less information. For example, we have the 1 lakh records for the same 10 groups. So here in each group, we will get the 10,000 records. So the information lies in the 10 records is very less compared to the information lies in the 10,000 record. So, if we want to apply our k-means, it's better to select largest data set. Okay.
Yes, ma'am.
Yes, at the starting, I had said two different clustering methods. One is the k-means, another one is the hierarchical. And how to go through the hierarchical. Let's take here flat clustering produces a single partitioning. First, what we'll do, we'll take single partition. First, that means randomly we'll take two centroids. We'll assign data points to the each centroid. Then after we'll again recalculate the centroid. Again we calculate the distance between that centroid to the each and data point which is lies under that cluster. Again we repartition that cluster. But coming to the hierarchical, we won't do like that. Hierarchical cluster can give different partitioning depending on the level of the resolution we are looking at. We'll say how we are differentiate partitioning depending on the level through the graph. We'll explain. Flat flat is nothing but k-means. K-means clustering needs the number of clusters to be specified. Here, if we want to build cluster model, we need to specify whether there is a k is 2, 3, 4, 5, 6. But for the hierarchical, we don't need to specify how many number of clusters does it have. Without specifying any number of cluster, it will differentiate the data points. Then after how to decide how many groups presented is, it's our decision. How we will take the decision, we'll say. In k-means clustering is usually more efficient runtime wise. Hierarchical clustering can be slow. Why k-means clustering means, for example, let's see. Through the elbow method, we are able to identify how many clusters, how many different patterns are presented in the data point. Whenever we give that data point, that many clusters to the model, automatically it will build model. Coming to the hierarchical, it will partition each and every level. How it will partition, will explain. For example, let's take uh, these are the A, B, C, D, E. We have the 5 data points. How many data points we have? 5 data points. Here we have the two types of hierarchical clustering. One is the agglomerative, another one is the divisive. Another one is the divisive. Let's take. In the first, we'll discuss about the agglomerative. Okay. Here, it will calculate the distance between the one data point to the other data point. A to B, A to C, A to D, A to E, B to C, B to D, B to E, C to D, C to E, D to E. It will calculate the all data points. It will assign, it will take which are two data points are very near. At a time, it won't combine 3 points also. It will combine only 2 points. Whatever the
Okay.
two data points very near, it will combine those two data points. For example, A and B are very near, so it combines. Here D and E very near, it combines. C, actually it will combine at the first time, it will combine only 2 points. So this data point is very far to these two. That's why it won't combine to the anything. Again, it will calculate the distance between this A, B and C. This A, B and DE. Again, it calculates C and DE. In
Ma'am,
this, okay,
I have a doubt. Like when the data points are in the spherical shape or else in the oval shape, how to find the centroid at that moment? Like if it is randomly moving, like it is randomly there when we represent, it's easy to find the centroid. Like when it's in
see,
spherical.
yeah. Uh, let's see. Here A means, for example, if we have the different houses, this A means that house information. It's not A, it is the circle, it is the semicircle. For example, let's take we have taken here age. This is the age data. This A is 10 years. This B is 12 years. This C is 13 years. Like that. For example, A 12 years, B 14 years, C 16 years, D 20 years, E 22 years. So it calculates the distance between these two. Here A means A is one data point, not A means A. It is one data point. It calculates the distance between this data point or this data point by using the same. There are a lot of algorithms, Euclidean distance,
No,
like that.
ma'am. Like my doubt is like when data points are in spherical shape, like when we represent in such a way, there will be a spherical shape of things, right?
Here
Like
there is no, let's say K means only depends on the centroids. Why? Because initially we will say there are five clusters, six clusters. Based on whatever number we will provide, it will take that many points as the centroids. But in hierarchical clustering, there is no centroids. There is no centroids. But how it will cluster, will say. Just how it combine data points, I am saying for now.
okay, okay. Yeah.
First, it will take each data point is the one cluster. For example, if we have the 100 clusters, 100 data points, what hierarchical clustering takes? There are 100 clusters. It will take the each data point as a centroid. It will take the each data point as a cluster. In the first level, what it does, this 100 data points into 50, 50 or 40, 60, whatever the data points near, it will combine into the one cluster. Again, it will calculate the distance between the one cluster to another cluster. It will combine again like this, CDE. Then after, at the end of the day, at the end of the top level, all the 100 points comes under one cluster. At the initial stage, it takes all 100 points is the 100 clusters. At the final stage, it takes the all 100 points into the one cluster. Let's say, we'll explain clearly. For example, in agglomerative hierarchical clustering is the popular method in cluster analysis data mining. It in iterative approach to create the hierarchical representation of the data objects. By successfully merging similar clusters, the primary goal is clustering technique is to group similar data points together based on their proximity, forming a tree-like structure known as dendrogram. That is, this one. Dendrogram means this one. For example, how it how it draw this dendrogram will explain here. For example, let's take agglomerative hierarchical clustering. Okay. Initially, what we'll do, each data point is considered as a individual cluster. That means,
It's same like parent chart, like
yes,
hierarchical
parent
chart
child.
which we'll be getting.
Yes. Let's take in agglomerative. If we have the 10 different data points, it initially it assumes there are the 10 different groups. For example, if our data set have the 1 lakh records, initially what hierarchical clustering assumes, we have the 1 lakh different groups. Then after, what will it do? It takes the each one. Then after, calculate the distance or dissimilarity measures between the all pairs of data points. That's what I'm saying. It will calculate the distance between this point to this point, this point to this point, this point to this point for the each and every point to the other point. Whatever the points which are very near, it will combine to the into one cluster. For example, let's take this is very far to the these all data points. That's why it won't assign any data point to the this data point for these three. Let's take these two. These two have the very less distance between these 2 points. That's why it combines it as the one cluster. Again, these 2 points have the very less distance, so it combines it into the one cluster. Then after what we'll do, identify two closest clusters based on the similarity measure and merge them into single cluster. For example, after clustering this one, these two data points into one cluster, these two into one cluster, and again these two into one cluster. What it do? It again calculate the distance between this cluster to this cluster. This is now one cluster. Previously it is the two clusters. Now this is the one cluster. The distance between this cluster to this cluster, this cluster to this cluster, this cluster to this cluster, like this. Then after it combines these two clusters, this cluster and this cluster into one cluster. Here also, this cluster into one cluster. Then after, repeat continue merging closest cluster iteratively until all data points belongs to single cluster. Until all data points comes one cluster. Initially, it takes each data point is a individual cluster. Then after, it will combine which are data points into one cluster. Again, it calculate the distance between the one cluster to another cluster. Again, combines till all clusters in all data points comes under one cluster. All data points comes under
Ma'am, first only
one.
if we could do that, that will be better, right? Why to do this first 4 steps?
First only,
Like why we need to do first 3 steps? Like at last we need all data points into one cluster, right?
yeah,
But
just means I actually, Akash, I did not completed this one. How do we calculate this cluster? How do we divide into the different clusters? We'll explain. Just this is how it clustering hierarchical in agglomerative hierarchical clustering. Okay. Dendrogram. The merging process is visualized as a dendrogram like this tree-like diagram showing the step-by-step merging cluster. The height of the dendrogram indicates the similarity between the merged clusters. Then after, let's take. First, initially we take each data point into the cluster. Finally, we have taken all data points into the under cluster. By seeing this graph, what we can understand? There might be two different clusters which are very far. For example, C. These data points is the one cluster and these data points are one cluster. By visualizing this group, what you feels? Hmm? This is one cluster. This is one cluster. Yes?
Yes, ma'am.
Yes. Actually, after you have cut dendrogram here like this, what will happen? You will get two clusters. This cluster and this cluster. Okay. But let's see this one. These 2 points are very far to this cluster by seeing. Yes, by observing this dendrogram, this particular one, this is the one group, this is the another group. Yes. So,
Ye-
if you feel these are the outliers, just you can cut this dendrogram here. So then you are able to differentiate this single cluster to 4 clusters. So, where you want to cut this dendrogram is your choice. In K-means cluster also, K the number of how many number of clusters we need to form, this is our choice. In our hierarchical clustering also, this is our choice. First you need to build all data points into under one cluster. Based on this dendrogram you
Ma'am,
can.
ma'am, sorry to
Yes.
interrupt. Like in K-means clustering, we need to do until elbow point, right?
Yes.
That's mandatory, or else
No,
we can
just
end as our wish.
actually K means we don't know how many patterns presented in the data point. That's why we are using the elbow method. But let's take elbow method suggest 5, 6, 7. But we don't know whether the data have the 5 or 6, 7. But instead of checking with 2 to 10, it's better to check with 5, 6, 7 clusters. Just for to identify the cluster, though, you don't go. There is no mandatory to use the that one that elbow method. That is one technique. Let's see. Whenever we have the problem, there might be some other technique to overcome that problem, to minimize the problem of the uh, minus points. For the K means, first we don't know the how many clusters presented in that. What we'll do, we'll need to check from the 2, 3, 4, 5. Let's say if our data have the only two groups or three groups, it's not might be a problem. For example, let's assume if our data have the 100 different groups of information, how much difficulty to calculate that one by from 2 to 100. It is very typical to find the whether the data point have the 100 different parts, 100 groups or 110, 90. In that case our elbow method will be useful. For example, if it suggests 90, 91, 92 or 90, 95, 100, what you will do, you will check with 90, 95, 100. So it is easy to identify there might be 90 to 100 clusters are presented, different groups are presented in that data. If we don't have elbow method, it's very typical. Just to identify, it is not mandatory to go with the elbow method. This is the time saving process. If for example, if you have the 100 points, by seeing 100 points, you are able to say how many different patterns are presented in the data. You directly say K is the 2 or 3. You don't need any elbow method. Here we don't
Okay.
have that type of elbow methods. Here we need to check with this dendrogram to cluster the to partitioning different cluster into the data.
Okay.
Yeah. First in agglomerative, we take each data point into the cluster. Then after we'll assign two data points into the one cluster, which data points are very near. Again, it repeats the till all data points into comes under one cluster. It will regroup the all the clusters into the combination of the two or three clusters into the one cluster. For the deceive, this is the just opposite version. Here, we'll complete first agglomerative. Agglomerative hierarchical clustering has some advantage, such as being relatively easy to interrupt and visualize. However, its main drawback it is the computational complexity. Here, I already told you in differences. Let's see. K-means clustering is usually more efficient runtime wise, but hierarchical clustering can be slow. Why? Because it is very typical. For example, if we have the 100 data points, it's okay. If we have the 2 lakhs, 3 lakhs data points, if we initially calculate it is the 2 lakh clusters, then after we need to combine each and every cluster. So it may take some time to compute. That's the disadvantage of agglomerative hierarchical clustering. So before performing hierarchical cluster, it is crucial to select an appropriate distance measure. That is linkage criterion. Means we have the different, I already told you, we have the different standardization methods. We have the x equal to x minus x mean by standard deviation. That is the formula for to normalize the data. But we have the different uh, algorithms. For example, standard scalar. Another thing is the normalization. Another thing is the range. But all algorithms do one thing: normalization of the data. Here also we have the different metrics: Euclidean, that is single linkage, complete linkage, average linkage. Different algorithms to calculate the distance between the one data point to the another data point. Whatever, so it is very important to select the which algorithm works for this data. So that is the one crucial point in the hierarchical clustering. Different choices can lead different clustering outcomes. If, for example, if you have selected single linkage algorithm, some data points comes under the one cluster, some data points comes under the one cluster. If you have selected complete linkage, at that time, for example, let's take in the single linkage, these 3 points comes under one cluster, these points comes under one cluster. Whenever you change this single linkage to complete linkage, there may be there is a chance to be these five data points into one cluster, these three data points into another cluster. So that's the another drawback in hierarchical clustering. Coming to the deceive means in agglomerative cluster, what it takes initially, it takes each data point into the separate cluster. In divisive cluster, first it consider all data points into one cluster. Then after, it will calculate the distance between the one data point to another data point. It cluster into entire data points into two clusters. It will divide entire data point into two clusters. Again, it will divide each cluster into different clusters till each data point comes under single cluster. Reverse process. Deceive hierarchical clustering is reverse process of the agglomerative. For example, all data points are considered as belong to the single cluster. Initial stage, it takes all data points into the single cluster like this. Then after, measure the dissimilarity, calculate the distance between the dissimilarity. Distance or dissimilarity, both are same between all pairs of data points. Just similar like agglomerative. It calculates the distance between the one data point and the another data point, and it divide this single cluster into two or three clusters based on the distance between the data points. It will repeat this step till reach until each data point is a single cluster into separate clusters or individual cluster till this time. Again form the dendrogram. Again we need to select where to cut this dendrogram to form into the clusters. Are you people able to understand what is the difference between the agglomerative and diffuse?
Yes, ma'am. But need to go and study by ourselves so that we can get more clear about it. We'll have any doubt, then we'll come back to this topic maybe again.
Okay.
Yeah.
So same deceive also have the same what are the drawbacks agglomerative hierarchical clustering have.
Okay.
This is the hierarchical dendrogram. See, decompose data objects into several levels of nested partitioning. That is the this for example, first for example, let's take the deceive. It will take the all data points into the single cluster. Then after it will partition. Coming to the agglomerative, first it will take the each data point into the single cluster. Then after it will combine the data points. So here the crucial point is the cutting. The clustering of the data objects is obtained by cutting the dendrogram at the desired level. Then each connected component forms a cluster. Here the main point is the cutting point. Where should we need to cut our dendrogram? Whether it is the two clusters, three clusters, or these six clusters, like this one.
Okay.
This is depends on our decision. This is the
Okay.
clustering. Uh, I think if you people miss anywhere, you can say I will explain again that part. In
And the
K
same,
means okay.
yeah, no, no, means when here only the thing you said no, means we have to cut the dendrogram. How we will decide from where to cut it? That is the
That is the problem. Just
yes.
what you do means same. What will do K means clustering.
So
First,
in the
we'll
same,
select 100% data set.
ah,
We'll do the one clusters,
yes.
different four clusters. Then after we'll select 90 or 80% of data. Again, we'll do the clusters. We'll check the data. For example, four clusters. The data points which are lies in the same cluster, we'll check at the initial stage whenever we do clusters whether the data points, for example, let's take the cluster 1, here also cluster 1. Here the data points, whatever the data points lies under the cluster 1, same data points are comes under the cluster 1 in the second time. If the both data points same in the cluster, whenever we do first clustering, whenever we do the second clustering, for example, train data, test data, so it is
Mm,
easy to understand you. First, we'll do some clusters with using train data. Again, we'll do the same clusters using test data. The data points which are lies under the train data cluster is same as the test data cluster. That means our clusters are good. Same approach we'll use here also hierarchical. What we'll do? First, we'll do the clusters into the, for example, let's take the here four clusters.
mm-hmm.
Then after
Okay.
you can check whenever new data points comes. Then after you can check, you can select 70% or 80% data. You know the whatever the data points under this cluster. You know the whatever the data points under this cluster. Yes, this
Yes.
cluster, this cluster, this cluster. You can take A B C D G H J K N. These are the some data points for the testing purpose. You can again cluster whenever you again cluster, you can check whether the ABCD forms under one cluster or whether the AB is goes to the one cluster or CD goes to the another uh, some other cluster.
Mm-hmm.
How many times you cluster? If ABCD comes under one cluster, that means your cutting is the good cutting. If let's assume whenever you by using the training data, ABCDE comes under one cluster. Then after you have selected some test data, 80% data. At that time, ABC comes one cluster, DE comes on other cluster. What you need to do? You need to do again cluster. At that time, you need to check whether ABCDE comes under one cluster or ABCD one cluster DE into another cluster. Based on that, you are able to identify the whether whatever the cutting you have selected is exactly what you are expecting or not.
Okay.
And don't worry, just like elbow method, we have the some other method to identify the dendrogram cutting also. We'll see everything on Jupyter Notebook. That's why this is the some hierarchical this algorithm have a lot of problems. That's why most of the people use K-means algorithm.
Okay. So, ma'am, one thing
This
here.
hierarchical is very very old algorithm.
Okay. How it decide? How means here in this diagram? How it decided that A, B, C, D, and E will be in one group or in one cluster, and F, G, H will be in one cluster like that? How it decided?
See, let's take we have the these are the data points. Whenever we cut, we get the cluster. That
Yeah.
means what we'll do, for example, for the A data point, B data point, C data point, E data point, we will assign one dependent variable that is the cluster 0.
Okay.
Then after we will assign FGH is related to the cluster 1. Then after IJK is the cluster 2. What we'll do again, we'll take the 70% 70% data, we'll do the clusters. So for those 70% points also have the uh, cluster 0, cluster 1, cluster 2 labels.
Mm-hmm.
So what we will do, we'll take these whatever the 70% data points we have taken for the testing, we select same data points from the train data. We have the two labels. Whenever we train, we have the one label, cluster 0 for these 70 data points. And whenever we use these 70 data points as the test 2, we have the label cluster 0, cluster 1, cluster 2. Then after we'll compare these two. Here we'll take train as the actual test or centroids as the. Okay, I will explain clearly for you. Here I have the 10 data points. Let's say this is the data we have. Then after by using elbow method,
Mm-hmm.
yes, we perform the clustering. See, this is
Okay.
the first cluster. This is the second cluster. This is the fourth. This is the third. Okay.
Okay.
So for these data points, we will assign. Let's take this cluster is the dependent variable. That is the outcome is always dependent variable. These are the input variables we used to build a model.
Yes.
This is the output we got. That is the dependent variable. What
Yes.
we'll do for these data points, we'll assign dependent variable. For example, these are the first 10 data points. We have the 40 data points. For the first 10 data points, we give the labeling 1. For the second 20, second 10, 2. Third 10, 4. Fourth one, 3. Then after we have taken 70. Sorry, these are the 40 records. Then after I have taken 30 records, which are uh, for the testing. Okay.
Okay.
Out of the 30, 7 comes under K1, 7 comes under K2, 7 comes under K4, 7 comes under K3. So for those 30 data points, I have now labels. For this 40, I have label K1, K2, K3, K4 for the first clustering. Then after I have selected 30 data points from this, again I performed K clustering. So I will get again for those 30, I will get K1, K2, K3, K4 labels. What we'll do, we'll take these whatever the 30 labels we have selected for this testing, we have selected those 30 labels from here. So for the training samples, I have the label. Now for the testing, whatever I used 30 data points for the testing, I have the label. We'll compare these two labels are same or not.
Okay.
If the two labels are same, then whatever the we did first clusters are the good. If the labels are different, that means the patterns, based on the patterns, the grouping is misclassified due to maybe whether it is the outliers, whether it is random noise, whether the whatever method we used, whatever the Euclidean distance, what is the distance, or what are the algorithm we used for the to calculate the distance. Due to some other reasons, our clusters fail.
Okay.
Like that, we will measure the quality of the k-means or hierarchical. See, guy, in classification, we have the label for the data. That's why we will build model one time. So we have the already labeled data. That's why we are splitting our data into two parts. We are splitting our data into 2 points. We'll use test data for the to measure the accuracy. Coming to the cluster, here we don't have the label to measure the accuracy. That's why what we are doing, we are performing, we are building two models. For the first model, we will get one label. For the second model, we will get another label. We will compare these two models results. If the two models results are same, then our model is good. If the two models results are not same, that means our model is not good. That's the what we are doing. We are doing to measure the quality of the cluster.
Okay.
People, guys, anybody have any doubts regarding this?
No, ma'am. Ma'am, we will code into the Jupyter, right, in coming class.
Yes, definitely. Please respond, other guys. If you people have any doubts, please.
No, ma'am. Nothing is there.
Yeah. Thank you. If you have any doubts, if you while repeating this concept again, if you have any, if you guys have any doubts, just ping me. We'll clarify.
Yeah, ma'am.
Yeah, sure, ma'am.
And
Yeah.
regarding the data, you said you'll say something.
Yeah.